Assalamu alaikum and welcome back everyone. Today we will be solving Physics Cambridge O-Level past paper. This is paper 2 from October-November 2024 and this is paper 2 variant 2. We have 1 hour and 45 minutes to solve this paper and the total marks for this paper is 80. Okay, so let's get started. Question 1. A jet ski is a type of boat that carries 1 or 2 people and travels at high speed on water. Figure 1.1 shows a student riding on a jet ski. A high-speed jet of water is forced backwards out the back of the jet ski by a pump inside the jet ski. So they are saying that a student is riding a jet ski and there is a pump right over here which is forcing water out of the jet ski. Question A. The pump increases the momentum of the water that is forced backwards out the back of the jet ski. Roman 1. Complete the word equation to show the relationship between the resultant force on an object and the change in momentum of the object. So basically we have to write the formula for resultant force according to the change in momentum. So we know that the resultant force is the rate of change of momentum. So we can write resultant force is equal to change in momentum divided by the time. Okay. Roman 2. In 2 seconds. In 2 seconds, the pump increases the backward speed of 180 kg of water by 30 meter per second. Calculate the backwards force exerted on the water. So to calculate the backwards force, we will be using the formula we just wrote. So force is equal to change in momentum divided by time. So we know that the equation for momentum is equal to mass multiplied by velocity. And therefore the change in momentum is equal to the change in mass multiplied by the velocity. So that will be, since the mass is constant, the change in momentum will be mass multiplied by change in velocity. Okay? So from the equation we can see that the time is equal to 2 seconds. The backward speed of water was increased by 30 meter per second. So the change in velocity is 30. And the mass of the water is 180. Therefore, the equation becomes 180 multiplied by 30 divided by 2. And that will become 270 Newton. So 270 Newton is the answer. Okay, moving on. Question B, Roman 1. Using Newton's third law of motion, explain why there is a forwards force on the jet ski. So what is Newton's third law of motion? Newton's third law of motion states that for every force, there is an equal and opposite force. Which means, since the pump is exerting a force on the water to move it forward, the water is also exerting a force on the pump. So we can write the jet ski exerts a force on the water. And therefore, the water will also exert an equal and opposite force on the jet ski. Roman 2. The student has a mass of 70 kg. And the jet ski has a mass of 280 kg. Use your answer from question A, Roman 2 to determine the acceleration of the student and the jet ski when no resistive forces are acting. So the question is asking us to use our answer from question A, Roman 2. In question A, Roman 2, we found out that the force of the water will be 270 Newton. So we have force is equal to 270. Okay. To find the acceleration, what we need is force is equal to mass multiplied by acceleration. Force is equal to mass into acceleration. So we have the force and we will find out the acceleration. So acceleration is equal to force divided by the mass. Now this part is important. What is the mass of the jet ski and the human? So the total mass is 70 plus 280. So mass is equal to 70 plus 280. So that will be 350. So 350 kg is the mass. So the acceleration is 270 divided by 350. So 270 divided by 350 is 7.7 meter per second square. So 7.7 is the answer. Okay. Question C. The jet ski reaches a speed of 20 meter per second. Calculate the total kinetic energy of the student and the jet ski at this speed. So this is an easy question. The kinetic energy formula is kinetic energy is equal to half multiplied by mv square. So once again, what is the total mass? 70 plus 280. So 350 kg is the total mass. So half into 350. And what is the velocity? The velocity is given 20 meter per second. So multiply by 20 squared. That will give us 70,000. 70,000 joules. So 70 kilojoule. So the kinetic energy is 70,000 joules. That is the answer. Okay, so now let's move on to question 2. A glass beaker of mass m is at rest on a horizontal surface. The base of the beaker is a circle with a radius r. Question A. The beaker exerts a pressure on the horizontal surface. Determine an expression for the pressure in terms of gravitational field strength G, M and R. So basically we have a beaker with a circular base. So this is a beaker and the base of it is circular. So we have to find the pressure the beaker exerts on the surface in terms of G, M and R. Okay. So the formula for pressure is force per unit area, right? So what is the force over here? The force here is the weight of the beaker. So that is the weight. So what is weight? Weight is equal to mass multiplied by gravity. Weight is equal to mass multiplied by gravity. So mg divided by the area. So by area we are talking about the base area, which is right over here. So the base area is a circle and the area of a circle is pi r squared. So therefore the pressure becomes mg divided by pi r squared. And therefore we have expressed the pressure in terms of mass, gravity and radius. So this is the answer. Okay. Question B. Figure 2.1 shows the beaker being filled with a liquid from container X. Initially the beaker is empty. At time t is equal to 0, the tap is opened and liquid from container X flows slowly into the beaker at a constant rate. At time t is equal to t, the liquid stops flowing into the beaker. So basically this beaker was empty and then from time t is equal to 0, the tap was opened and the liquid from container X flowed right into the empty beaker and filled it up. And at time t is equal to capital T, the liquid was stopped from flowing into the beaker. So the liquid was flowing from time t is equal to 0 to t is equal to capital T. Okay. Let's see the question. Sketch on figure 2.2 to show how the pressure exerted on the horizontal surface varies between t is equal to 0 and t is equal to 2 capital T. So we have to show the graph of how the pressure on the horizontal surface was varying between t is equal to 0 and t is equal to 2t. T is equal to 0, the tap was closed and the only pressure working on the horizontal surface was the mass of the beaker. Okay? There is a constant right here. You can write it right over here. It was the mass of the beaker. So at T is equal to 0, the tap was opened and the liquid was flowing inside the beaker at a constant speed. So there will that was flowing until T is equal to capital T. So from 0 to T there will be a constant increase in the pressure. So there will be a straight line like this. Okay. And from T to 2T there was no change in pressure. Why? Because the tap was closed at T and therefore the pressure was constant from there onwards. So we can draw it like this. So this is the graph. So now we will move on to question 3. Figure 3.1 shows a laboratory freezer. The door is closed and the freezer is switched on. A cold liquid is pumped through the copper pipe at the top of the freezer. The temperature of the air next to the copper pipe decreases quickly. Question A. Explain how the temperature of the rest of the air in the freezer decreases. Okay, so let's understand what's happening here. So cold liquid is pumped through this copper pipe and due to that the temperature next to the copper pipe will decrease. And whenever they ask how the temperature of a fluid is increasing or decreasing, what you have to do is describe convection currents. Because heat flows through any fluid through convection currents. So due to convection currents, the air close to the copper pipe will decrease in temperature, and we know that cold air is denser, so it will sink to the bottom. And the warm air will rise to the top, and this will set up convection currents inside the freezer. So let's explain this here. So as temperature of air around the pipe decreases, the air will contract and its density will increase. So the cold air will sink to the bottom. So the hot, less dense air will rise up to the top, and this will cause convection currents. And this is our answer. Okay. Question B. The thick insulation shown in figure 3.1 is made from a plastic material. Roman 1. The plastic material in the insulation is poor thermal conductor. Describe how thermal energy is transferred through a plastic material. So the insulation, which is the door and the walls of the container, are made of thick insulation plastic. So we have to answer how thermal energy is transferred through a plastic material. So since plastic is a solid, the thermal energy will be transferred through conduction, and it is a non-metal. So we will have to describe how heat travels through a non-metal. So the particles will first vibrate and collide with each other, and this collision will result in energy transfer. Vibrate and collide with each other. And then transfer energy. Roman 2. The plastic material also contains a large number of small air bubbles. Explain how the air bubbles reduce the transfer of thermal energy through the insulation. So this is a common question. I've seen it repeat many times in past papers. So the reason air bubbles reduce the transfer of thermal energy is because air is an insulator of heat. So air will stop conduction and it will reduce convection. So the air trapped inside the bubble reduces heat transfer. So for 3 marks we can write Air is an insulator of heat. Air is an insulator of heat, so it stops conduction and convection. Therefore, the air trapped in the bubbles reduces heat transfer. So the air in bubbles and this is enough for 3 marks. Now we will be starting question 4. Figure 4.1 shows a large syringe that is sealed at the nozzle by wax. There is a piston inside the syringe. So this is a syringe, there is a piston right here, and the end of the syringe, which is the nozzle, is sealed with wax. The pressure of the air inside the syringe is equal to atmospheric pressure 1.0 into 10 to the power 5 Pascal. So the pressure right here is 1.0 into 10 to the power 5. The volume of the air inside the syringe is 1.2 into 10 to the power minus 4 cubic meter. So the volume is also given for this air. The area at the end of the piston that is in contact with the air is 3.5 into 10 to the power minus 3 square meter. So that means this area is 3.5 into 10 to the power minus 3 square meter. The friction between the piston and the syringe is negligible. Question A, Roman 1. Calculate the force on the piston due to the pressure of the air inside the syringe. So basically we have to calculate the force that is being put right here on the face of the piston. So the force here is the pressure on the air. Pressure is equal to force divided by the area. So we have the pressure and we have the area. So to calculate the force, we will write force is equal to pressure multiplied by the area. The pressure is 1.0 into 10 to the power 5 and the area is 3.5 into 10 to the power minus 3. So 1.5 into 10 to the power 5 multiplied by 3.5 into 10 to the power minus 3. So we will get 1.0 into 10 to the power 5. So we will get 3.5 into 10 to the power 2 Newton, and that is the force. Roman 2. The force on the piston in question 1, Roman 1, acts to the right. Explain why the piston does not move to the right. So the force that we just calculated is acting on the right like this. The question is asking us to explain why the piston is not moving. So the reason is because the atmospheric pressure and the force on the piston is equal. So the atmospheric pressure is acting on the left right here. And since these two are equal and acting in the opposite direction, they will cancel each other out and the resultant force will be 0. So let's just write it. Force due to atmospheric pressure is acting on the left. They cancel each other out, and so there is no resultant force. Question B. The piston is now pulled to the right by an additional force. The temperature of the air in the syringe does not change. Roman 1. Explain in terms of particles why the pressure of the air in the syringe decreases. So now the piston is moved to the right and the temperature remains constant. We have to explain why the pressure will decrease inside the syringe. So when it is pulled to the right, the volume of the air will increase. The volume of the air will increase, and so the particles are now further apart from each other. And the particles will collide less frequently with the walls of the syringe and with each other. So that's why the air pressure will decrease. So that is basically Boyle's law. Since the volume will increase, the pressure will decrease. That is Boyle's law. So we can write the volume of air increases. So the particles are now further apart. They collide less frequently with the walls of the syringe and the piston, so that's why the air pressure will decrease. Okay, Roman 2. Calculate the pressure of the air inside the syringe when the volume is 1.5 into 10 to the power minus 4 cubic meter. So when the volume is 1.5 into 10 to the power minus 4, we have to find the pressure of the air inside the syringe. So let's look at the question again. We already had the volume and the pressure that was before. So that will be P1 and this one will be V1. So P1 is equal to 1.0 into 10 to the power 5 and V1 is equal to 1.2 into 10 to the power minus 4. So according to Boyle's law, P1 V1 is equal to P2 V2. So P1 is 1 into 10 to the power minus 10 to the power 5. And V1 was 1.2 into 10 to the power minus 4. And V2 is equal to 1.5 into 10 to the power minus 4, and we have to find P2. So when you calculate this, you will see that P2 is equal to 8 into 10 to the power 4 Pascal. 8 into 10 to the power 4 Pascal. So P2 is equal to 8 into 10 to the power 4. And we are done with question 4. Okay guys, now let's get started with question 5. Some glass lenses are converging lenses and others are diverging lenses. Question A. Draw the cross section of a diverging lens. Okay, so diverging lenses are thinner in the middle and thicker at the top and bottom. So they look something like this. Yeah. It's supposed to look something like this. Okay, so question B. Figure 5.1 shows the cross section of a converging lens, the principal axis and the two principal focuses, focal points f1 and f2 on a full scale grid. So this is a converging lens. This line over here is the principal axis and two focal points are labeled f1 and f2. Oh, and also we have a full scale grid. We can see here that we have a scale here where 1, 2, 3, 4, 5. 5 small boxes are equal to 1 centimeter. So that means one small box is equal to 0.2 centimeter. And this is true for both x-axis and y-axis. A student places an object of height 2.1 centimeter at a distance of 3 centimeter from the center of the lens. Roman 1. Using figure 5.1, determine the focal length of the lens. So we have to use figure 5.1. Let's check the figure again. So the focal point is nothing, just the distance between any focal point and the center of the lens. So let's count the number of boxes over here. we have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. There are 9 boxes from the center of the lens to F1. And we know that one box is equal to 0.2 centimeter. So 9 boxes will be equal to 0.2 multiplied by 9, that is 1.8 centimeter. So the focal length is 1.8 centimeter. Roman 2. On figure 5.1, draw a vertical arrow of height 2.1 centimeter, that is 3 centimeter from the center of the lens, and label the arrow O. The arrow is the object. So basically we have to label the object on the diagram. The object's height is 2.1 centimeter and the distance from the center of the lens is 3 centimeter. And we also have to label the arrow as O. So since it is 3 centimeter away from the center of the lens and each centimeter is represented by 5 boxes, we have to count 15 boxes from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it will be around here. And the height of the object was 2.1 centimeter. So that will be 11 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the arrowhead will be around here. Now let's draw an arrow. Okay. Roman 3. On figure 5.1, draw 2 rays from the tip of the object arrow to find the tip of the image. Draw another arrow to show the image. So what we have to do first is we have to draw 2 rays from that arrow we just draw to find the image position of the lens. And then we have to show another arrow to mark the position of the image. Now let's go back to the diagram again. So we have to draw 2 arrows. So anytime they ask you to draw the position of a image of a lens, you have to draw 2 arrows. The first line will pass through the optical center of the lens. So it will pass something like this. And then you will extend it. Okay. And the next arrow will be parallel to the principal axis. Something like this. And once you enter the center of the lens, it will then bend to pass through the focal point on the other side. So it will bend to pass through F2. And again you will extend it. Okay. Now you can see that the 2 lines are meeting at this point. And this is the point where the image of the object will be formed. So they asked us to mark the image using another arrow. So we will draw an arrow from the principal axis up to this point. And the arrow will be downwards because the arrow is always extended from the principal axis. So it should go like this. Yes, this is the final drawing. Now, question Roman 4. Using the image marked in figure 5.1 in B Roman 3, determine the linear magnification produced. Now, what is the linear magnification? So, the linear magnification is nothing, just the image height divided by the object height. So, the object height is given as 2.1 centimeter. And let's go back to the diagram again. Okay. Now let's check the height of the image we just draw. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 boxes, and 18 multiplied by 0.2 is 3.6 centimeter. So the height is 3.6. So 3.6 divided by 2.1. 3.6 divided by 2.1 is 1.7. 1.7. So the magnification is 1.7. Okay. If your answer is close to 1.7, the answer is correct. Okay. It should be around 1.3 to 1.7. Okay. Roman 5. Explain whether the image of the object is real or virtual. So how do you understand if the image is real or virtual? So you have to understand that if the image is formed by two of the light rays converging together and meeting at a single point, the image will be real. And if the light rays do not meet at a single point, the image will be virtual. So in this diagram, the light rays are converging and they meet at this single point. So that means that the image formed is real. And also the question is asking us to explain why it is real or virtual. So first you will write real, and then you will write since it is formed by converging light rays. So since image is formed by converging light rays. Now let's start question 6. Figure 6.1 shows the circuit symbol for a relay and two labeled terminals. Question A. By referring to figure 6.1, explain the effect of a current passing from A to B. So we have two labeled terminals here, A and B, and in the middle we have a magnetizing coil. And on the other side of a magnetizing coil we have a relay switch, and we can see that the switch is open. So now what will happen when a current passes through A to B? So when a current passes through A and B, the magnetizing coil will become magnetic. So there will be a magnetic field, and this magnetic field will attract this relay switch, and this relay switch will then close. So we can write when current passes, the magnetizing coil produces a magnetic field. And this magnetic field attracts the relay switch, which closes the circuit. Question B. Figure 6.2 shows two circuits linked by a relay. The heater transfers energy at a rate of 40 watt when it is connected to a 12 volt supply. Switch S is closed. So this switch will be closed. The variable resistor is adjusted so that its resistance R increases from 0. So there is a variable resistor here. Its resistance was 0 and then it increased from 0. Okay. So first let's check the diagram carefully. We have another relay switch, and on the other side of the relay switch there is a magnetizing coil. And this magnetizing coil is connected to a variable resistor. And the relay switch is connected to a heater of 12 volt power supply. So one thing to note is that the heater is not connected with this supply. The heater is only connected to this 12 volt supply. Okay. Let's see the question. Figure 6.3 shows how the power transferred in the 40 watt heater varies as R increases from 0. The graph shows a sharp decrease when the resistance R reaches RH. So the diagram shows that the power used to be 40 watt while the resistance was increased from 0 to RH. And then when the resistance hit RH, the power decreased sharply to 0. Okay, explain the shape of the graph in figure 6.3. We have to explain why the power suddenly decreased to 0 from 40. Okay, now let's look at the diagram again. What exactly is happening here? When the resistance of this circuit of the magnetizing coil was increased, what happened to the current? So we know that V is equal to IR. And the voltage is this supply. Okay. So the voltage will remain constant, and when R is increased, the current will keep on decreasing. And when the current keeps on decreasing, the magnetic field of this magnetizing coil will keep on becoming weaker. And at one point it will become too weak that it will not be able to attract this relay circuit. So this relay circuit will become open again. And when this relay circuit will open, there will be no current flow inside the heater's circuit. So therefore the heater's power will quickly decrease to 0 when this relay switch is open. So in short, what exactly is happening is when the variable resistor's resistance is increased, the current of this first circuit will keep on decreasing, and this will cause the magnetizing coil to become weaker, and the magnetic field of the magnetizing coil will become weaker. So before, this relay switch was closed, and when the magnetizing coil's magnetic field became weaker, it opened up again, and therefore this heater circuit opened, and that's why the power of the heater sharply decreased to 0. So we can write, initially the current of the coil is large and the switch is attracted to the magnetizing coil, and therefore the switch is closed. As the resistance increased, the current decreased, and therefore the magnetic field of this coil was decreasing. And at last the relay switch cannot be closed because the magnetic field was too weak. Okay. Moving on to question C. The 40 watt heater connected to the 12 volt supply is switched on again. Calculate Roman 1. The energy transferred in the heater in 2 minutes. So we know that the energy transfer equation is E is equal to PT, and the power of the heater is given as 40 watt. So the power is 40 watt, and the time is given 2 minutes. Now an important thing is that the time should always be written in seconds. So 2 minutes is 2 multiplied by 60, 120 seconds. Therefore the energy will be 40 multiplied by 2 multiplied by 60. And that will be 4,800. So the energy transferred is 4,800 joules. Okay. Roman 2. Calculate the resistance of the heater. So the resistance can be calculated using the power and the voltage. So the power is V squared divided by R. Therefore the resistance is V squared divided by the power, right? So the voltage is given 12. So 12 squared divided by power 40. And 12 squared divided by 40 is 3.6 ohms. So the resistance of the heater was 3.6 ohms. And with that we are done with question 6. Now for question 7. The frequency of an alternating current mains electricity supply is 50 Hz. The maximum voltage in the supply is 300 volt. Question A. Using the axis in figure 7.1, sketch a graph to show how the voltage of the supply varies in a time of 0.05 seconds. So basically we have to sketch the graph here, and we know that the maximum voltage of the supply is 300 volt and the frequency is 50 Hertz. So how are we going to sketch that? First, we will have to find out the time period of the graph. So the time is equal to 1 by frequency, right? So 1 by 50, that will be 0.02 seconds. And the maximum voltage is 300 volt. So at time 0, the voltage will be 0, and the entire circle will be completed by 0.02 seconds, and the maximum will be 300 seconds. So therefore the peak will be right over here, and another peak will be minus 300. Okay. So the graph should look like this. This is how the graph should look like. So when you're drawing on paper, try to make the line more smooth. It's not possible to do that with a pen tablet here, but you see the idea. Question B. Figure 7.2 shows the mains power supply connected to the primary coil of a transformer. The primary coil has 750 turns. So that mains supply, the alternating current is connected to a primary coil here, and the primary coil is connected to an iron core. And the iron core is connected to a secondary coil here. Roman 1. The core of the transformer is made from iron. Explain why iron is a suitable material for the core of the transformer. So the reason all of the transformers use iron for their core is because iron is easily magnetized and demagnetized. So we can write iron is a temporary magnetic material. Okay. Roman 2. Explain why there is a voltage across the secondary coil. So we have to explain why the main supply alternating current is creating a secondary coil voltage. So the reason is because the alternating current from the main supply is creating the alternating current in the primary coil is creating magnetic field lines in the core. The magnetic field lines look like this. And these magnetic field lines are cutting the secondary coil, and therefore there is an induced EMF or an induced voltage in the secondary coil. Therefore we can write the alternating current in the primary coil is creating magnetic field lines in the core. And these magnetic field lines are cutting the secondary coil, and this leads to induced EMF or voltage in the coil. Now Roman 3. There are 60 turns on the secondary coil. Calculate the maximum value of the voltage across the secondary coil. So that means the number of turns in the secondary coil is 60. And we already know the number of turns in the primary coil is given as 750. And we have to find the maximum value of the voltage in the secondary coil. So the maximum value in the primary coil was given as 300 volt. And the formula is NP divided by NS is equal to VP divided by VS. NP divided by NS is equal to voltage of the primary coil divided by the voltage in the secondary coil. So 750 divided by 60 is equal to 300 divided by something we have to find out. So after calculation, we can see that the maximum voltage in the secondary coil will be 24 volt. And therefore 24 volt is the maximum voltage of the secondary coil. Now we will be starting the easiest question in this entire paper. Question 8. The isotope thorium-230 decays by alpha particle emission. Question A, Roman 1. Describe the composition of an alpha particle. So we know that the alpha particle is represented like this, 4 alpha 2. And this means that the proton number is 2 and the neutron number is 4 minus 2 equal to 2. Okay. Roman 2. State the name of the particle that is identical in composition to an alpha particle. So this is helium nucleus. Okay. Question B. The alpha particle decay of thorium-230 produces an isotope of radium. Deduce, Roman 1, the number of neutrons in a neutral atom of this isotope of radium. So before we answer this question, let's check out the proton and neutron number of radium. We can do that by subtracting an alpha particle from the thorium isotope. So 230, 90, thorium minus 4, 2 alpha. So 230 minus 4, that is 226, and 90 minus 2, that is 88. And this is the radium isotope. So the number of neutrons in this atom of isotope, in this isotope of radium, will be 226 minus 88. And 226 minus 88 is 138. So the number of neutrons is 138. Okay. Roman 2. The number of electrons in a neutral atom of this isotope of radium. So in a neutral atom, the number of electrons is equal to the number of protons. So the number of electrons will be 88. Okay. Question C. The half-life of thorium-230 is 75,000 years. A radioactive sample contains 7.2 into 10 to the power 16 thorium-230 atoms. Determine the time it takes for the number of thorium-230 atoms to decrease to 9 into 10 to the power 15. So this is also another easy question. All you have to do is keep on dividing 7.2 into 10 to the power 16 by 2 until you reach 9 into 10 to the power 15, like this. 7.2 into 10 to the power 16, when you half it, you will first get 3.6 into 10 to the power 16. And when you half it again, you will get 1.8 into 10 to the power 16. And again halving it, we get 0.9 into 10 to the power 16. So 0.9 into 10 to the power 16 is nothing, just 9 into 10 to the power 15. So therefore we have 1, 2, 3. So we have 3 half-lives in between. And we have to find the time it takes for the entire thorium-230 atom to decrease to 9 into 10 to the power 15. So it takes 3 half-lives. And we have to give the answer in years. And 1 half-life is 75,000 years. Therefore, 3 half-life is 3 into 75,000. That is 2.25 into 10 to the power 5 years. So 2.25 into 10 to the power 5 years. That is the answer. Okay, moving on. Question D. When it decays, thorium-230 also emits gamma radiation. Figure 8.1 shows a narrow beam of gamma radiation passing into an electric field. Okay. Question Roman 1. On figure 8.1, sketch the path of the gamma radiation in the electric field. So we have to sketch the path the gamma radiation is taking when going through this electric field. And one thing to note is that gamma radiation has no charge, so therefore the beam of gamma radiation will not be deflected at all. It will just go through a straight line like this. And that is the answer. Okay. Roman 2. On figure 8.2, show the electric field replaced with a magnetic field that is directed onto the page. On figure 8.2, sketch the path of the gamma radiation in the magnetic field. So once again, we have to sketch the path of the gamma radiation, but this time it is a magnetic field. And once again, the gamma radiation will not be deflected. Instead, it will go through a single line, single straight line, like this. And the reason is because gamma radiation has no mass, and therefore it will not be affected by the magnetic field at all. Now let's move on to the last question of this paper. Question 9. The Earth has a radius of 6.4 into 10 to the power 6 meter and rotates on its axis once in every 24 hours. Question A. Figure 9.1 shows that as the Earth rotates, objects on the surface of the Earth move in circular paths around the axis of rotation. So basically what they are saying is this is the axis of rotation of the Earth, and the Earth is spinning on this axis. And objects on the surface of the Earth are also moving in circular path as the Earth is moving. Okay, Roman 1. Calculate the speed of an object at the equator as it moves in a circular path around the axis of rotation. So if an object is situated on the equator, we have to find the speed of the object as it moves in a circular path. So the speed is calculated by distance by time. And what is the distance here? The distance an object covers on the equator is nothing, just the circumference of the Earth. Why? Because let's look at this. As it moves around the equator, it will cover a distance that is equal to the circumference of the Earth. And the circumference is given by 2 pi r. And what is the time? It says it takes 24 hours to move on the axis. So 24 hours in seconds. So 24 into 60 multiplied by 60. That is 24 hours in seconds. And the radius is given 6.4 into 10 to the power 6. So 2 pi 6.4 into 10 to the power 6 divided by 24 into 60 into 60. And calculating it, we get the answer 470. So the speed of an object on the equator is 470 meter per second. Roman 2. Explain why the speed around the axis of rotation of an object on the Earth decreases as the distance of the object from the equator increases. So the reason the speed will decrease as the distance from the equator increases is because, let's think of this as the Earth, and this is the axis of rotation, and this is the equator. As you move away from the equator, the radius, the object from the axis will keep on decreasing. And that is why the speed will decrease, because the speed is dependent on the radius. So 2 pi r divided by t is the speed. And as the radius decreases, the speed will also decrease. So the radius decreases as distance from the equator increases. And that is the answer. Question B. The Earth moves around the Sun because a force acts on the Earth. Roman 1. State what provides this force. This is the easiest question here, okay? The reason the Earth moves around the Sun is because the Sun has a gravitational field and the Earth is moving around the Sun because of this gravitational field. So we can write the Sun provides gravitational field. And this causes the gravitational force. Roman 2. The orbit of the Earth around the Sun is an ellipse. So what is an ellipse? It is an oval shaped orbit. So like this. And this is the Earth, and on the middle is the Sun. Describe what happens to the magnitude of the force that acts on the Earth as it moves in this elliptical orbit. So basically it is telling us what happens to the force, the magnitude of the force when the Earth moves around the Sun in an ellipse. So check this out. When the Earth is closer to the Sun, the gravitational force will obviously increase, and when the Earth is further from the Sun, like this, the gravitational force will decrease. So basically the magnitude of the force will be variable. So we can write the force will be variable. It will increase when the Earth is closer to the Sun and decrease when the Earth is further apart. Roman 3. Explain why the Earth travels the slowest when it is at the furthest distance from the Sun. So we have to explain why the Earth is traveling the slowest when it is at this part of the ellipse. So the reason is because the gravitational potential energy will increase as the distance increases, and therefore the kinetic energy will decrease as the speed will be least. So we will write the gravitational potential energy. So we will write the gravitational potential energy increases as the distance increases. So the kinetic energy decreases and the speed is the least. And the speed is the least when it is furthest from the Sun. And that is how we are done with October-November 2024 Paper 2 Variant 2. Let me know which paper I should tackle next. Okay, bye everyone.